Dear students, so we had seen in the morning, in the first video, definitions of complex integration, right? So I started the unit complex integration. So you know what is simple closed curve, multiple curve and connected region. When can we say the region is connected? If we find 2 points and we join those 2 points as a curve, if the curve lies entirely in the region, then the region is said to be connected. And you know what is simply connected region and multiple connected region. What is simply connected region? If there is a region, and if you consider C in the region, a closed curve in the region, if the region of C lies in the region, then we say the region is simply connected region. Okay, right? The region is simply connected region, and this is multiply connected region, right? When we have holes, then the region is multiple. I showed you example in the morning, right? That is multiple connected region, otherwise simple connected region, right? So now we have discussed in the morning Cauchy's integral theorem. Very important, listen here, statement of the theorem will be asked in 2-mark question. See, integral over C f of z dz is 0. When the answer will be 0? When the function f of z is analytic and the derivative of f of z is continuous at all points inside and on the curve C. C will be given in the problem. So inside and on every point of the simple closed curve C, if it is continuous, the derivative is continuous, then the value of the integral is 0. You can see here there is no denominator, right, in Cauchy's integral theorem. So you should know difference. Cauchy integral theorem, Cauchy integral formula and Cauchy's integral formula of derivatives. Okay, so you should know difference. So the extension of Cauchy's integral theorem. So you will go through this, it is enough. Next comes Cauchy's integral formula. What is Cauchy's integral formula? Integral over C f of z, we have denominator z minus a dz, which is 2 pi I into f of a. The value of the integral is 2 pi I into f of a. When the value is 2 pi I into f of a, when the function is analytic inside and on the simple closed curve C, and this A is a point which lies inside the curve C. C will be given in the problem. You have to check whether the point A lies inside the curve or outside the curve. If it lies inside the curve, then the value of the integral is 2 pi I into f of a. Okay. So you can understand this when we do problems. Okay. Next comes a formula of derivatives with the same condition defined when we have the term whole square, whole cube. In the morning, I did mistake, listen here. If it is power 2, you can see we have 1 factorial. If it is power 3, we have 2 factorial. Here it will be n factorial if the power is n plus 1. In the morning, in the video, listen here, this plus 1 is missing, okay? You please include it. Here it should be n plus 1. So that it becomes n factorial. Please correct it in the morning PDF, okay? So now it is ready to do problems. Before doing problems under the heading Cauchy's integral formula, Cauchy's integral theorem, etc., first let us do a simple problem which is different from all those things. See, this problem is, we have already done this model problems. The only difference is here with the function is f of z into dz. We have already discussed in Green's theorem, right? Before Green's theorem, line integral, right? In line integral, we discussed integral f of x dx. Integral f of x dx with x limit, right? Integral. Here you can see it is integral f of z dz. We know z is x plus iy and dz is dx plus i dy, right? With the limits, complex limits. So the same way of integration what we did in line integral, okay? There is nothing new here. Anyhow, the unit starts with this kind of problem. So namesake I have done one problem. It is enough. Okay? And I have given you a problem as homework. Though it is one problem I have done for 3 subdivisions, okay? We have to evaluate the integral. First, along the line joining z equal to 0, z equal to 1 plus I. How will you plot z equal to 1 plus I in xy plane? X coordinate is 1, x plus iy actually. X is 1, y is 1. So how will we mark 1 plus I in xy plane? 1, 1. This is 0 plus I 0. So we plot it as 0, 0 in xy plane. So the line joining 0, 0 and 1, 1. So first question is the line joining the point 0, 0 and 1, 1. So if you draw diagram 0, 0, 1, 1 and when you join those two, you can clearly understand it is a straight line. It is a straight line passing through origin. What is the equation of line passing through origin? X equal to y or y is equal to x. So see, the line joining z equal to 0 and z equal to 1 plus I is that is the line joining the point 0, 0 and 1, 1 is y is equal to x. Being line integral, so it should be either for a variable, either with a variable x or with variable y. Okay, either with a variable x or with variable y. So in order to get all x or all y, we have to use y is equal to x or x is equal to y. If y is x, then dy becomes dx. Let us now take the given integral. Let us change all to x by replacing y by x. dz becomes dx plus I dy, where dy is also dx. Now we have to integrate this. Take constant terms out, integrate, substitute limits, you will meet answer. You can stop here. I have rewritten it as a plus ib form. No need, okay. Next, the same, we have to evaluate the same integral for the second curve, y is equal to x square. See, y is equal to x square. That is dy is equal to 2x dx, right? So you have to change it to a single variable, x or y. So you can easily replace y by x square. If you want to change x in terms of y, then x becomes x square equal to y, x becomes root y. X becomes root y, okay? So which may be complicated while integrating, okay? That's why let us replace y by x square. And in place of dy, 2x dx. And now split the integral. This is not the only way to integrate, okay? You can do in your own way, integrate, get answer, okay? You can do in your own way integration. And third subdivision in Cartesian form, x in terms of t, y in terms of t given. So we have to find the value of the same integral, okay? You can see it is minus 1 by 3 plus 1 by 2i. Here also the answer is minus 1 by 3, different. It is different. It is different, right? Here you can see the points are 0, 0 and 1, 1. So we are going to change all to the variable t. X in terms of t, y in terms of t, it is given. So that you can find dx. What is dx in terms of t? What is dy in terms of t? So dz becomes dx plus I dy. All in terms of t. We need limits of t. Let us take when x is 0, y is 0. When x is 0, y is 0, our t will be 0. When x is 1, y is 1. T is 1. When y is 1, you can see 2t minus t square equal to 1. Simplify. You will find two answers t where 1 is suitable because they both should have same values of t. T is equal to 1. Once you know limit of t, next it is integration. There are many ways to integrate. You can do it in your own way. I have followed here. Listen here. First term into first term into second term. It's your choice of integration. You can do it anyway. Find the answer. Ordinary simplification. Limit substitution and simplification. Answer is minus 1 by 3 plus 1 by 6i. Okay. And similar problem is given to you as homework. Evaluate. Integral 0 to 2 plus I. Okay. Similar problem is given to us homework. So we have started with line integral problem with complex limits. Right. So since we have done already this model problems in the last unit, I have done here one problem with 3 different subdivisions. And I have asked you a homework with 2 different subdivisions. And listen here, it is not being important. Here the problem starts. If it comes, you should know. That's why I have done. Okay. Dear students, let us continue now with the problems of Cauchy integral theorem. Okay. So now what is Cauchy integral theorem? Integral over c f of z dz. Answer will be 0 if the function is analytic function. Okay. C is given. The curve C is given mod z equal to 1. You know mod z equal to 1 is a circle. Modulus of x plus iy is equal to 1. Root of x square plus y square equal to 1. So x square plus y square is equal to 1. So Modulus of x, z is equal to 1 is a circle whose center is 0, 0 and radius is 1. Okay. So C is given and f of z is e power 1 by z. So you can easily conclude the problem. It's 2-mark question it is. It is 2-mark question. There is no denominator. So it's very clear. This unit is 4th unit. And the 4th unit, if 2-mark question comes like this, then we use Cauchy integral theorem. It will be very clear. Function is analytic. You need not test whether it is analytic or not. F of z is analytic inside and on C. C is mod z equal to 1. What is mod z equal to 1? Modulus of x plus iy equal to 1. X square plus y square equal to 1 square. Circle with center 0, 0 and radius 1. Okay. See, f of z is analytic inside and on C. So by Cauchy integral theorem, the value of the integral is 0. Next, evaluate this. N is not equal to minus 1. C is mod z minus 2 equal to 4. It is also a circle. Mod z minus 2 is equal to 4 is a circle. See, x plus iy minus 2 is equal to 4. Group real part and imaginary part separately. See, it is root of x minus 2 whole square plus y square equal to 4. Squaring both sides. See, mod z minus 2 equal to 4 is a circle whose center is 2, 0 and radius is 4. Okay. So they have given a circle C. C will be here simple closed curve. So definitely circle. And there is no denominator. Find, evaluate means find the value. Find the value of the integral is evaluate. So to evaluate this integral, f of z is z minus 2 whole power n. F of z is analytic inside and on C. Definitely you need not test. By Cauchy integral theorem, answer is 0. 2-mark question. Okay. Now you can see this is the first problem with the denominator. F of z dz by z minus a. Integral over C f of z by z minus a into dz. So this is the first problem with the denominator. So you have to use Cauchy integral formula now. Okay. So first 2 problems with it is from the heading Cauchy integral theorem. Now it is with Cauchy integral formula. F of z is cos pi z. C is mod z equal to 2. Mod z equal to 2 is circle. Okay. X square plus y square equal to 2 square. Circle. See, C is mod z equal to 2. What is the statement of the theorem says? Integral over C f of z by z minus a into dz. Z minus a. A is 1 here. A is 1. F of z is cos pi z. C is mod z equal to 1. A is 1. And you have to test what the statement of theorem says. This Cauchy integral formula says. You have to test whether this A lies inside the curve. If A lies inside the curve, then the value of the integral is 2 pi I into f of a. If this a lies outside the curve, then the value of the integral is 0. Let us test whether this one lies inside the curve. There are 2 ways to test this, whether this one lies inside the curve or not. There are 2 ways. First way is, see, consider the curve. Put z equal to a. We have what? You go through statement. They say z equal to a is a point lies inside the curve. Z equal to a. A is 1. So you please substitute z equal to a. Mod 1. Which is equal to 1. Mod 1 is 1. 1 is less than 2. If 1 is less than 2, then z equal to 1 lies inside C. In case if it is greater than the given value, then it lies outside C. Okay. There are 2 ways to test whether the point lies inside the curve or outside the curve. Let us go through once again the theorem, Cauchy integral formula. What is Cauchy integral formula? See, f of z is analytic, that you need not test, okay? It will be analytic. If the question is under Cauchy integral formula, it will be analytic. The one thing you have to do is whether a lies inside C, z equal to a, lies inside C or not, okay? So to test z equal to a lies inside C or not, there are 2 methods to test. 2 methods. The first method is consider the curve, put a, z is equal to 1, z is equal to a is 1, hence put z is equal to 1, mod 1 is 1, If the answer comes as less than this number, then z equal to 1 lies inside C. If it lies inside C, then the value of integral is 2 pi I into f of a, where a is 1. F of 1. F of z is cos pi z. F of 1 is cos pi. Cos pi is minus 1, hence answer is minus 2 pi I. I said there are two methods to test. You can see the second method. Second method, diagram method. What is diagram method? You draw first mod z equal to 2. Circle with center. Mod z equal to 2 is circle with center. See, how will we identify the value of a? You should equate the denominator to 0. So z equal to a. A is 1. Z equal to a. A is 1. You have to check whether z equal to a lies inside the curve or not. So this is one method. If you feel difficult, you can go for second method. That is, see, mod z equal to 2 is circle with center 0, 0 and radius 2. So all four sides with radius 2 I have drawn a circle. What is z equal to 1? The meaning 1, 0. 1 plus I0 actually. That is 1, 0. If you mark 1, 0. 1, 0 lies inside the curve. Hence z equal to 1 lies inside the circle. So there are two methods to test. But I prefer this method. Every time drawing diagram and verifying is, listen here, it's easy, but it will take time. Okay, you have to identify what is center, radius, etc. So this is easy. Being first problem, it may be, you may feel difficult. When we do more number of sums, it will become easy. See, what are the steps? First you write f of z. Next you write c. Next you consider z minus a actually. A is 1. You have to substitute this one in the given curve. If the answer comes as less than the radius, less than 2, then it lies inside the curve. If it lies inside the curve, the value of the integral is 2 pi into f of 1 by Cauchy integral formula. Hence, how will you find f of 1? From f of z. Put z equal to 1, which will complete problem. Okay. Now we started Cauchy's integral theorem problems, right? And we did two problems using Cauchy integral theorem. Then it's a Cauchy integral formula. Using Cauchy's integral formula, we did a problem. I know a problem is not sufficient. Okay, we should do some more so that you may feel easy. Let us see. This fifth problem over. Evaluate integral over c 2z square minus 4z plus 3 whole divided by z minus 2 dz, where c is the circle mod z minus 2 equal to 1. And listen here. Here when they ask you to evaluate, definitely f of z will be analytic function. You need not test whether it is analytic or not. F of z is analytic function. So it is integral over c f of z by z minus a into dz. So f of z is analytic function. So the only test what we do is we have to test whether this a lies inside the curve or outside the curve. To test whether it lies inside or outside, what we do is, there are two methods. One is you take the curve given, our a z minus a is 2 here, substitute 2 minus 2 which is 0, the answer 0 is less than 1, hence this z equal to a lies inside the curve. It is z minus a. You have to test z equal to a lies inside the curve. When z minus a becomes z equal to a, when z minus a is equated to 0. So z equal to a lies inside C. By Cauchy integral formula, the answer of the integral is 2 pi I into f of a. Our a is 2. F of 2. F of z is known. Substitute 2. You will get f of z. F of 2. Answer is 6 pi I. Let us see another problem of the same model. It is integral f of z by z minus a into dz. And you have to test f of z is analytic, no problem, because it's a find the value. So you have to test whether this a lies inside the curve or outside the curve. If it lies inside the curve, answer is 2 pi I into f of a. If a lies outside the curve, answer becomes 0. Let us write f of z. What is c given? C is mod z equal to 1. A is 2 here. Substitute a equal to 2 in z because z is equal to a. So modulus of 2 is 2, which is greater than 1. Which shows this z equal to 2 lies outside the curve. Hence, answer of the integral is 0. I told you there are two methods. There are two methods to find answer, right? I told you. To check whether the point lies inside or outside. If you go through last problem, what is modulus of z minus 2 equal to 1? The curve mod z minus 2 is equal to 1. That is x minus 2 whole square plus y square equal to 1. Mod z minus 2 equal to 1 is a circle whose center is 2, 0 and radius is 1. Let us draw such circle with center 2, 0 and radius 1. And we have to test whether this z equal to 2 lies inside or outside. What is the meaning z equal to 2? What is the meaning? Z equal to 2. Z equal to 2 is the point 2, 0 because 2 can be written as 2 plus I0. So you have to test whether this 2, 0 lies inside the curve or outside the curve. It lies inside the curve. Hence, we can use Cauchy integral formula, right? So every time drawing diagram and verifying whether the point lies inside or outside will take some time. It will take some time. So this is the easiest method, okay? And here the answer is 0 because the point lies outside the curve. You can see the similar problem. F of z is z, a is 2, c is mod z equal to 1. Answer, when you substitute 2 here, modulus of 2 is 2, which is greater than 1. Hence the point lies outside curve. If you want, you can test. If you want, you can test using diagram. There are two methods. You can use even diagram to test whether the point lies outside or inside. See, mod z equal to 1 is circle with center 0, 0, x plus iy is equal to 1, which is not root of x square plus y square equal to 1 or x square plus y square equal to 1 square. It is circle with center 0, 0 and radius 1. Radius 1. Center 0, 0. You have to test whether this z equal to 2, right? A is 2. Z equal to 2 lies inside or outside. Z equal to 2 means 2, 0. 2, 0 lies outside the circle. Hence, the value of the integral is 0. So, you can use this method directly substituting in C, finding answer, or you can use this diagram method. Your choice, okay? Dear students, after 8th problem, this is 9th problem of the unit 4, complex integration, which comes under the same heading, Cauchy's integral formula. So, you know the definition of a simply connected region, multiple connected region, and in the theorems, Cauchy integral theorem, Cauchy integral formula of derivatives, okay? And we are doing problems under those headings. So here you can see question is evaluate integral f of z by z minus a into dz. Z minus a, which shows a is minus 1, okay? Z minus a. So we need not verify whether the function is analytic. Listen here, to find the value of the integral, we should use Cauchy's integral formula because we have denominator with z minus a. So we should use Cauchy's integral formula. So to use Cauchy integral formula, the statement says f of z should be analytic function and z equal to a should lie inside the circle, inside the curve. So we should, if these two are true, then the value of the integral is 2 pi I into f of a, which is the formula. So we need not check whether the function is analytic or not. When they ask us to evaluate, f of z will be analytic. So the only thing we need to do is whether a lies inside the curve or not. So here a is minus 1. To check whether this z equal to minus 1 or a is equal to minus 1 lie inside the curve, what we do is there are two methods. We know we prefer direct substitution method. Curve is mod z equal to 2. Let us substitute a is equal to minus 1. Z is equal to a actually. When z is minus 1, answer of modulus of minus 1 is 1, which is greater than the given answer. Hence, z equal to minus 1 lies outside the curve. Value of integral is 0. If you see 10th problem, integral over c. So this is the first problem with product of terms in the denominator. Okay. So when it is product of terms, what we do is the very first step, we should see what is a and what is the other a. Two a's we have, right? A and a. What is c here? Let us have column. First you substitute a is equal to 1 here. 1 minus 2 is modulus of minus 1, which is 1. The answer is greater than 1 by 2. Hence, z equal to 1 lies outside, or a is equal to 1 lies outside c. When it is 2, 2 minus 2 is 0, where 0 is less than 1 by 2. Hence, it lies inside c. Though we have product of two terms, and one of the terms lies outside the curve, other one lies inside the curve. Let us have in the denominator the term which lies inside the curve. Let us keep the term which lies outside the curve in the numerator. That is, we rearrange. See, take this z minus 1 to numerator, which becomes our f of z. This is our f of z, okay. So our f of z is new now. There are two terms, product of terms, the denominator. So we check if they both lie inside c. Let us see how the method is. If both lies outside c, answer becomes 0. If one lies inside c and one lies outside c, let us take the term which lies outside c to the numerator. So that this is our new f of z now. F of z by z minus a into dz. Okay. We have already tested whether it lies inside or not. We can directly write by Cauchy's integral formula. Answer is 2 pi I into f of a. So this left hand side remains same. Okay. Left hand side remains same. Just we have rearranged f of z. Rearranged the terms given. F of a is f of 2. F of z is z by z minus 2. 2 by 2 minus 1. Answer is 4 pi I. Okay. Let us see. We have again it is z minus 1 into z plus 1. There are two terms in the denominator. Product of terms in the denominator. Let us take a1, a minus 1. Let us test whether they lie inside c or not. One lies inside c, other one lies outside c. So this z minus 1 lies outside, z equal to minus 1 lies outside c. So take this term to numerator so that that becomes f of z. Denominator becomes z minus 1, which becomes z minus a. So f of z, since z equal to 1 lies inside c, by Cauchy integral formula, 2 pi I into f of a. F of z is this one. Hence f of 1 is 1 plus 1 by 1 plus 1. 2 by 2, answer 2 pi I. Okay. You can see next there are, listen here, product of terms. Once we have product of term, this is the method. You can see both lies inside c. When both lies inside c, there are two methods to do problem. There are two methods. I have given both methods. I have written this side a method. See, I will give you in PDF only this method, okay? But in video, I have given you both methods. The first method is, since both lies inside c, take this term to numerator and z minus 3 will be denominator. Or take z minus 3 to numerator, this will be in the denominator. Since both lies inside c, you can write it as sum of the two. Where when one is in the denominator, other one will be in the numerator, right? Since both lies inside c, we can use Cauchy integral formula. The value of the integral is 2 pi I into f of a. 2 pi I into f of a. But you should know, f of z is different for this f of 3. F of 2 is different for this. F of z is different for this f of 2. When this is f of z, you can find f of 3. When this is f of z, you can find f of 2. Now answer becomes 2 pi I into 13 plus 2 pi I into minus 8. Hence answer is 10 pi I, which is one method. This is easy. Other method is also easy. The other method is, take entire term. Use partial fraction method. Both are linear factors, right? Which can be written as a by z minus a plus b by z minus b. Both are linear factors, so very easy resolving it into partial fraction. So when you take LCM, both denominators get cancelled. Hence numerators are equal. Put z equal to minus 3. This term will become 0. You can find answer of B. Put z equal to 2. B will become 0. You can get answer of A. Substitute the answers of A and B in first equation. Now integrate. Integral over C. Integral over C. Hence the value become 2 pi I into f of A plus 2 pi I into f of B. When you see f of z in the numerator, which is 1. Here also f of z is 1. F of z is 1. If f of z is 1, f of 2 is also 1, f of 3 is also 1. Whatever z takes, answer is going to be 1. Because there is no z to substitute in the right hand side. Hence answer is 10 pi I. You can follow any method which one is easy. Okay. Dear students, it is continuation of the heading Cauchy integral formula. Let us see the 13th head question. Evaluate the value of the integral. Where the curve C is the closed curve, simple closed curve, mod z equal to 4. Mod z equal to 4 is circle whose center is 0, 0 and radius is 4. That is x square plus y square equal to 4 square is the equation of the circle. We have product of two terms, the denominator. Let us take both A. Is that z equal to 2 or A equal to 2, A equal to 3. Let us check whether they both lie inside C or outside C. Put A is equal to 2 here. Modulus of 2 is 2, which is less than 4. Hence, z equal to 2 lies inside the circle. Put z equal to 3. Modulus of 3 is 3, which is also less than this 4 given. Hence, z equal to 3 lies inside C. Z is equal to A is a point which, if it lies inside C, then the value of integral is given by Cauchy integral formula. Otherwise, answer is 0. So, there are two methods to do problem. When we have both terms, the denominator, both product of terms here we have, right? Both points lie inside C. There are two methods. One is partial fraction method. Both are simple factors. Do by partial fraction method. Find the values of A and B. Substitute it here. I hope you know this method, right? We have already discussed in the last semester. Find the values of A and B. Substitute it here. Hence you see, integrate the f of z by z minus a into dz, f of z by z minus a into dz. Where in both the integrals f of z is 1. In both integrals f of z is 1. Hence the answer of integral is 2 pi I into f of a, f of 2, f of 3. In both integrals f of z is 1. So f of 2 is 1, f of 3 is 1. Whatever z takes, answer becomes 1, right? So you know second method. If you feel this method easy, you can go through. Keep a term numerator or this term plus integral over C, the other term in the numerator, right? Which is 2 pi I into f of a. The only thing you should know is you can find f of 2 using this f of z, f of 3 using this f of z, right? Hence you find f of 2 and f of 3, substitute it here, you will get answer. You can use any one of the method, either partial fraction or this method, okay, which can give you answer, okay. Next I have given you some simple problems, homework. If it is difficult, I have given nearby hint. You please try homework sums, otherwise, listen here, unit is not easy, okay. If you do not do homework sums, it is not easy. Let us see some other problems. See different model. The denominator, it is quadratic form. Let us take it in rough work. Find the values of z. Being quadratic, we will have two values of z, right? Two roots. These two are called roots. Usually in Cauchy integral formula, the denominator we will have factor, not root. Z equal to A is a root. Z minus A is a factor. Let us get this term this side. See, I have written. This can be written as Z minus A into Z minus A. Because Z equal to A is a root, Z minus A is a factor. Z equal to A is a root, Z minus A is a factor. We need factors in the denominator, right? Now which is of the form integral f of z by z minus a into dz. There are two terms in the denominator, product of two terms in the denominator. Let us check whether they both lie inside C or any one lie inside C, etc. Take A's. See, what is C? Mod Z minus I is equal to 2. Modulus of Z minus I. Okay. This is circle actually. If you want center and radius, you can find it. X plus Iy minus I is equal to 2. It is X plus I into Y minus 1 is equal to 2. X square plus Y minus 1 whole square equal to 2 square. Center is 0, 1, radius is 2. You need not know such things. I tell you, this is circle. Okay. Let us take the circle, substitute A here in place of Z. It comes modulus of A plus IB form, which is root of A square plus B square. Answer is root 2, which is 1.4 less than 2. When you substitute next to A here, see, answer is root 10, which is greater than 2. Hence, this lies outside C and this lies inside C. Hence, integral over C f of z by z minus a dz becomes, listen here, since it lies outside C, we can take this factor to numerator, which will become f of z. Okay. Answer is 2 pi I into f of a. Our a. 2 pi I into f of a. This is our f of z. This is our a. By Cauchy integral formula, answer is, if both lie inside C, we use partial fraction method or another method, right? Here luckily one lies inside C and one lies outside C. Hence it is easy. See, 2 pi I into, substitute the value a in f of z, you will get f of a. Simplify, you will meet answer. Okay. You know, we are in the heading Cauchy's integral theorem and Cauchy's integral formula. And this is another problem, f of z by z minus a into dz, where C is mod z equal to 3. Circle with center 0, 0 and radius 3. F of z is z plus 3. To find a, equate the denominator to 0. So that z is equal to a. A is minus 5 by 2. A is minus 5 by 2. You have to test whether it lies inside C or outside C. Modulus of minus 5 by 2 is 2.5, which is less than 3, it lies inside C. Hence, by Cauchy's integral formula, the answer of the integral is 2 pi I into f of a. F of minus pi by 2. So, f of z, replace z by minus 5 by 2, you will get answer. And I have given you a problem as homework. Now comes the new problem. Listen here. It is a problem of Cauchy's integral formula of derivatives. You can see the denominator. So we had done many problems earlier where there will be no whole square, whole cube, etc. It is z minus a simply, where we use Cauchy integral formula. Now we have to use Cauchy integral formula of derivatives. F of z is z square plus 1, where c is mod z equal to 1.5. A is 1 here. Test whether it lies inside C or outside C. The same method, okay. The answer of the integral is 2 pi I by 1 factorial into f dash of A. That is what the Cauchy integral formula of derivative says. Cauchy integral formula of derivatives, integral over C f of z by z minus a whole square dz is 2 pi I by 1 factorial into f dash of A. Our A is 1 here. How can we find f dash of A? We know f of z. Find f dash of z. Replace z by 1. You will get f dash of 1. F dash of 1 is, replace z by 1. F dash of 1 is 2. Okay. See. F dash of 1 is 2. Substitute here to find answer. Very simple, okay. Just formula is different when you have whole square in the denominator. It is f of z by z minus a whole cube. They have given z equal to a lie inside the circle, closed curve C. Usually we verify whether it lies inside or outside. Here no need, they have given it lies inside C. F of z is given, z minus a whole cube. Since it lies inside C, answer of the integral is 2 pi I by 2 factorial into f double dash of A. That's what our Cauchy's integral formula of derivative says. Integral f of z by z minus a whole cube dz is 2 pi I by 2 factorial into f double dash of a. How will you find f double dash of a? First you find f double dash of z. Later replace z by a, get f double dash of a. F of z, f dash of z is uv method. Keep u, differentiate v. Keep v, differentiate u. Again f double dash of z. Keep u, differentiate v. Keep v, differentiate u. Again differentiate the term. Replace z by a. Substitute it here, problem over. Okay. You can see next comes the same model problem with whole square. But when you look at the problem, you can easily guess. Now you are familiar. Since a is 3, modulus of 3 is 3, which is greater than 1. Hence it lies outside the curve. Hence the value of integral is 0. You can see next problem. It is the first problem with product of terms in the denominator. That too a term with whole square. So as usual, first you take a. What is a? Now listen here. Test whether they both lies inside or outside or any one lie inside, etc. A is 1. Mod 1 is 1, which is less than 1.5. 3 by 2 is 1.5. When you substitute minus 2, it is 2, which is greater than 3 by 2. Hence this point lies outside C, this point lies inside C. So this point is Z plus 2. Take it to numerator so that it becomes f of Z. So this is the only term in the denominator which lies inside C. The point lies inside C. So by Cauchy integral formula, the answer is 2 pi I by 1 factorial into f dash of 1. F dash of a is 1 here. First you find, this is our f of Z. First you find f dash of Z. Put Z equal to 1. Find f dash of 1. Substitute it here. Get answer. Okay. Get answer. Dear students, we are seeing problems under the heading Cauchy integral formula of derivatives. When you look at the denominator, when we have whole square, whole cube, etc. comes, we should use formula of derivatives. So f of z by z minus a whole square dz, right? So let us equate the denominator to 0 and we identify what are the factors. Okay. See rough work. Z square plus 1 whole square 0. That is z square plus 1 0. That is z square equal to minus 1. That is z equal to plus or minus I. Z is plus I and z is minus I. These two are roots. Hence z minus I, z plus I are factors. When z equal to I is a root, z minus I is a factor. Z plus I is a factor. This whole square, which can be written as a into b whole square, is a square b square. Let us rewrite the given integral as a square b square. We have product of two terms in the denominator. So you have to choose. Listen here, you have to check whether I and this minus I lies inside the curve. When a is I minus I is 2i. I minus I is 0. 0 is less than 1. When a is minus I, which is minus 2i, it is root of a square plus b square, a plus ib form. Root of a square plus b square. Answer is greater than 1. Hence it lies outside C and this point lies inside C. So let us keep the term which lies outside C to numerator, the other one in the denominator. So we have f of z now. It's very clear it lies inside the curve. So being whole square, we should use Cauchy's formula of derivatives. The value of integral is 2 pi I by 1 factorial into f dash of a, where a is I. A is I. To find f dash of I, first we have to find f dash of z. First you find f dash of z. F of z, f dash of z. Find f dash of I. Substitute in the answer, you will get final answer. It's a similar problem, okay? Similar problem. F of z by z minus a whole cube. It's very clear it lies inside C. Answer is 2 pi by 2 factorial into f double dash of 1. To find f double dash of 1, first we have to find f double dash of z. From f of z, find f double dash of z. Replace z by 1, you will get f double dash of 1. Hence, which is the answer? We have some problems, homework. The first heading is over, okay? So the next heading is Taylor series and Lorentz series.